Hello and welcome. I welcome you once again to our channel where we handle issues in mathematics and physics at all levels. And today we want to look at what we call the inclined plane. Of course, the inclined plane is an area in mathematics in the section of mechanics. And we are going to analyze how issues and how many problems can come on the inclined plane. Now, before we can go into details, I want students to know that when we are dealing with the inclined plane, we can have two possible things. So the case we're looking at initially, the body may be in equilibrium. So we are likely to talk about a body in equilibrium, and then we are also going to talk about a body in motion. So when whatever we're going to be doing, a body can be in equilibrium or it can be in motion. When it is in equilibrium, the examiner will tell you it is in equilibrium or it is at rest. And when it is in motion, he will still tell you. So it is important to note in the beginning that if the body is in equilibrium, our resultant force on the body is going to be zero. And if the body is in motion, the resultant force is going to be equal to mass times acceleration in the direction of motion. All right. So that is very, very important to note. And then now, in the beginning, let us consider a body that has been given to us. This is a body. Let us say the body is of a mass, and the mass of the body is m. So we shall do everything here by, first of all, looking at the forces acting on the body. I want to assume that this body has been placed on a smooth plane. That means if the plane is smooth, we actually do not have friction on the body. So what actually happens, what forces act on this body? First, number one, acting on the body, we are going to have the weight. The weight acts on the body. And remember, we say that weight is always equal to mg. So if weight is equal to mg, and this is weight, so we can actually say mg, because the mass is mg is acceleration to gravity, which g, by the way, is always equal to 9.8 meters per second squared. That is force number one. Then force number two is what we call the normal reaction. So we have the normal reaction R. And this normal reaction, like we say, the normal reaction, you call it the normal reaction, it is normal to the plane. So if you can allow me to do this, I can produce this here. So this is the vertical, and so the normal is along the vertical. The reaction is along the vertical. And then here, let me say I have my horizontal. That is the horizontal. So what I'm putting dotted lines is simply to show you that this is horizontal axis and this is vertical axis. But the forces are only two. The forces is the weight, number one, and force number two is the reaction. Those are the only two forces we have acting on this body. If the body is, we have no external force, the moment you put it on an inclined plane, these are the two forces which will act. That is reaction and weight. So we have no external force in this case. Mark you, one other thing you should see is that if this angle is theta, the angle in this position here will also be theta. And so that is actually what we have. And so what are we going to do when we are analyzing issues here? There are very many things a student can do. One thing I always advise students to do is to come and analyze the forces here. So, of course, when you look at, I've just told you that this is the horizontal and this is the vertical. Now, for starters, I'm going to actually advise you to reproduce this in a way that is more appealing to you, more understandable and more easy to see. Though we are doing this as starters, as time moves along, we shall not do this part, but for now, let's have it. This is our vertical axis, so I'll be sure that I have a vertical axis. This one is the vertical axis, and then I have the horizontal axis. So this is vertical and this is horizontal. Now I'll go to the other step and see now along the vertical, which forces am I having? Along the vertical, I have reaction, which reaction is acting upwards, is pointing the upward direction. We advise students to do these forces using a ruler. Yeah. And then in the first quadrant, I have nothing, so I'll put nothing. Second quadrant, nothing, I'll put nothing. Third quadrant, I have the weight. And so here, I'll put my weight, mg, and the angle in that position is theta. Of course, in the fourth quadrant, I have nothing. This was reaction. And so this is what I have, and I'm assuming that this body is actually at rest. Those are my forces acting on the body. And so the other step, after doing this, the student is going to go ahead and obtain the resultant force. Obtain the resultant force. And we are quite sure that if I talk about resultant force, which I normally call Fr, I'll do a resolution for each force. Remember, we can resolve in many ways. I always love you to use the column form, where here we always put the horizontal component and here we put the vertical component of the force. And so I'll come and look at every force that is in this diagram here. So force number one, I have the reaction. And so I ask myself, does the reaction have a horizontal component? We can say the reaction is purely vertical. It has no horizontal component. So horizontally, it is 0. And then vertically, it has a component. It's moving upwards, so that will be positive. So there I have my R. And then plus, I come to the other force. The force is mg. Now, of course, this mg, we resolve it. It has both horizontal and vertical. Horizontal is going to the left, so it will be negative. That is minus mg sine theta. And then vertically, it's still minus mg cos of theta. And those are the only forces I have. If I had another force, I would gladly add that force, but I have no force. So if the body is in equilibrium, like if it is in equilibrium, we shall say this is equal to 0, 0. Okay? And then if it is in motion, of course, on the plane, motion is normally along the horizontal. So horizontal, it will be equal to ma, and vertical, it will be still 0 because vertically the body does not move. So we do this, we equate this to that. If the body is in motion, and we shall do this if the body is in equilibrium. Okay. Now, in our next videos, we are going to look at the 3 cases that can come, because like you can see here, I do not have an external force acting on this body, and yet it normally happens that I have forces. So we shall look at those cases. Case number 1, we shall look at a force which is acting parallel, or let's say the force is acting along the line of greatest slope. That will be our case number 1. And then case number 2, we shall say, what if the body, the force is a horizontal force, and then I look at the force acting at an angle to the line of greatest slope. So when we do these 3 cases, we shall call it a session. Otherwise, I want to thank you for watching this video up to the end. I remain Habizana Samuel. I encourage you to subscribe and like, comment, put your question in the comment section, and I'll gladly respond to your question. I thank you for watching.